Okay, I think we're good to go.
Okay. Hey guys, hey everybody, thanks for joining us on our new web series for your weekly Texas Sky Update. My name is Ashley and I am a science educator and console operator at the University of North Texas Sky Theater. And I'll be moderating in the comments off to the side of the video. Um, and you can ask any of your questions to our presenter that you may have about space and astronomy, and I'll try to relay those questions to him accordingly. So our show will consist of a tour through our night sky this week, and since this is a kids show hour, we will be showing a kids themed astronomy movie at the end of the Star Talk. So our presenter today will be using a software called Stellarium, which is a free program that you can download at home on your own computer. So if you like what you see here today, you can go to this. You can go to the website and download it. I will post a link in the comments so you can check it out for yourself. So our weekly Sky update is completely free to view live and anytime after we're done, and it's posted on Facebook after the stream ends. However, since we are not running in person live shows anymore in our planetarium at the moment due to the pandemic, it has left us without a way to generate any kind of revenue. So, if you'd like to help out to sustain and advance our program, you can do so by donating. I will also post a link in the comments along with the Stellarium link as well. So yeah, you can donate whatever you want. If you are unable to donate, please raise awareness by liking and following our Sky Theater page, um, and sharing our shows and with your friends and family as well. That would help us a lot if we could um, spread this website or spread our Sky Theater page throughout the community here. It'd be great. So yeah, with that all being said, I would like to finally introduce you to our presenter, our Star Talk presenter, Cade.
Hello. Thank you very much, Ashley.
Yep.
All right. So I'm going to be controlling your screen that you're viewing here. So I'm going to minimize Ashley, but she's still going to be around, and she's just going to moderate any comments or questions you might have in the Facebook. But thank you very much, Ashley. All right. So here we are. I'm using a program called Stellarium, and if you bear with me for just one moment here, what I'm going to do next is I'm actually going to minimize my own little video so that I'm not eating up the whole portion of the screen
Yeah,
here.
you can donate
Uh,
whatever you want.
and
If you're
then
unable to donate, please raise
what I'm going
awareness
to
by
do
liking. And
is
that
I'm
being
actually going
said,
to
I would like to
use this
finally
program here
introduce you to our
and
presenter, our Star Talk presenter.
start us off from where we would usually
Hello.
start.
Thank you very much,
So
Ashley.
the way that this works
right.
is
I'm
it
gonna
will
be,
automatically open up to
controlling
whatever
your screen
date
that you're
and
viewing
time
here, so I'm gonna
you're currently
minimize
looking
Ashley,
at it.
but she's still gonna be
So
around,
I'm
and
going to
she's
just
just
set
gonna
it
moderate any comments
to
or
today's
questions you might
date
have in
and
Facebook.
the current time, which is around 2 p.m., but it uses actually the 24-hour clock here, which is going to be around 14 p.m. Or 1400. And then it might look a little bit strange because I have a few other settings turned off, so there we go. That looks a little bit more like the regular daytime sky that I'm used to. And this is what Stellarium is going to
Thank
look
you very
like
much,
whenever you
Ashley.
first open the program. It's going to
So,
basically take you
here we
into
are.
what you
I'm
can
using a
see in the sky at that moment in time. Now, what I can also do with this here, start us off from where we... There we go. What I can also do with this here, of course, is I can change our location. So we can hover over the bottom left side of the screen, and we can actually pull up a bunch of different menus. There's a lot of buttons on the bottom, and then on that left corner, we can go over here, and that's how I have the date and the time window pulled up, is just by clicking that second option there. If I open up this first menu, it's the location window. Now the location window here allows you to control where you are when you're going to be viewing the night sky. You can click this box right here to get the location from your network, or what you can also do is just type in the name of the city or place that you'd like to be located to see the night sky. Our Star Talk today is going to be centered, pardon me, around Denton, Texas. That's where I'm located. That's where the UNT Planetarium is located. And that's where we're going to be doing our Star Talk today. So I'm going to close out this window here. And the first thing I'm going to do is I'm going to set it to be actually nighttime. So I'm going to change this to be about 10 o'clock, so 2200 hours. And there it is. It's automatically showing us what the sky is going to look like tonight. Of course, in Denton, we're not able to really see quite as many stars as you can see on your screen right now. I'm just going to use my mouse here, and I can actually left click and kind of drag around to get a nice view of the sky. And you can also zoom out to kind of get a better angle. So I'm just going to zoom out a little bit there. And of course, here in Denton, we actually have something called light pollution. Everybody around the world experiences this, especially if you live in a densely populated area. Anytime we have car lights or street lights or house lights on at night that we use to see and navigate around, of course, when it's dark, well, all of that light actually lingers in our atmosphere. This is called light pollution. Our eyes actually focus where light is produced. So what happens usually
Hey,
is
Cade.
that we're unable to... Go ahead,
Hey,
Ashley.
Cade, I'm sorry. You might want to mute the Zoom audio.
Oh,
We got
thank you.
feedback going on.
Oh, thank you. Sorry about that. Hopefully we didn't destroy anyone's ears with the feedback there. Thanks, Ashley. So in Denton, Texas, we have light pollution. This prevents us from being able to see most of the starlight that's out there. So a lot of times what happens is our starlight will actually not be as strong as the light we produce here on Earth. So this creates this light pollution effect where light that we create outside at night lingers in our atmosphere, and our eyes focus more on that light that's really close to us than we do on light that travels from stars that are light years to thousands of light years away. So what we can do, however, is I'm going to show you only stars and constellations that are going to be easy to see on any given night, or on tonight in particular. So I'm going to left click and drag around so that we actually face north first. That's the important thing that we do whenever we're looking at the stars, is we want to make sure we know what direction we're facing to make it easier to determine what we're looking at. So right now we're facing south, as you can see at that big red S at the bottom of your screen. So I'm just going to left click and drag over until we're facing north. And the reason that we face north is because of the North Star, of course. The North Star is a very important point in the sky, and it's not a particularly large or bright star, actually. It's not even really close to us. It actually is important because the North Star never moves. The North Star never rises and never sets. This right here is the North Star Polaris. I'm just going to left click on that. Now anytime we left click on a star here in the program Stellarium, we're going to get all this nice information that pops up on the left side. So I'm going to minimize some of that information. To click away from a star, I'm just going to right click away, and then I'm going to go over here into the configuration window. In the configuration window, under information, I'm just going to click none. And then I'm going to click the first three on the left column, and then I'm going to click visual magnitude, type, size, and distance, just so we have a cool little list of info, but not something that completely clogs the left side of the screen. And then the next thing I'm going to do while I'm already here is I'm going to go click on Tools, and then I'm going to click Select Single Constellation. And that's going to make it a lot easier to actually just look at one constellation at a time in the Stellarium program. Alright, now when I left click on Polaris, the North Star, it's just going to give me a little bit of information, and the first thing it says is the name. Right under here it says AUMI. UMI means Ursa Minor, and that's actually the constellation that the North Star Polaris is located in. So I'm going to hover over the bottom menu here, and the very first button on the left there is Constellation Lines. You can also just use your hotkey on your keyboard, the letter C, and turns on the constellation lines for that constellation, or for the star that you've selected. So I'm going to zoom in a little bit here. And one cool thing about Stellarium is that a star's size, so how big a star looks on your computer screen here, actually is reflective of how bright or how easily visible this star is. So Ursa Minor in the North Star is a bit of a strange constellation to spot, pardon me. And the reason I say that is because you can really only make out this star right here, the North Star, and then these two stars over here. If you notice, especially right here, the size of these two stars is much larger than all the little stars that are in between that also make up this constellation. So whenever you're looking out at night, usually you'll only be able to see this one and then these two here at the end, which make up Ursa Minor. But you might be wondering, how do I even find this group of stars? When you go outside, it's going to be kind of vague. There's just going to be a bunch of stars. It's not these nice lines to connect everything, of course. But what we can use is Ursa Major, the Big Dipper. You might already be able to see it, but the Big Dipper is this group of stars right here. Now, the Big Dipper actually only makes up about half of a larger constellation known as Ursa Major. Ursa Major here, also known as the Great Bear or the Large Bear, actually has these two nice stars right here. These two stars we can use as pointer stars, and they'll send us directly towards Polaris. And that's an easy way you can find the North Star whenever you're out looking at the night sky, is finding your pointer stars that come from Ursa Major. You can also use, in case it's fall or winter time and you don't see Ursa Major is closer to your horizon, you can also use this constellation right here, Cassiopeia. Cassiopeia is a nice little arrow, and it points you in the general direction of where you can find the North Star, Polaris. So earlier I said that the North Star is important because it never moves. Well, what does that mean? Well, basically, Earth is a big planet out in space, and we actually orbit around our own axis. We are, of course, orbiting around the sun, but while we move around the sun, we're also spinning around our own axis. And as we spin around our own axis, that axis is just kind of an imaginary line that goes through the center of our planet. This imaginary line comes out of our north and our south pole, and the North Pole, as it turns out, is pointed directly at Polaris, this star right here. So, a few different ways that we can kind of show you how this works, is by opening up the date and the time window again. And if I open up the date and the time window, I can actually use this time button down here. I can speed up the clock using the little fast forward button. You can double or triple click it. And then you can watch all these nice stars orbit around Polaris here. And you can see, of course, the clock will speed up really fast. I'm going to pause it there and bring it back to around 10 or 10:30 when we were looking at it. And you can also, of course, just do this by clicking over here on the clock window and going through the motions of Earth rotating around its axis, making it look like all the stars in the night sky are moving around us. It's kind of like if you were ever on a merry-go-round and you look up. Or maybe if you have an office chair with wheels on it, you can spin around in your chair, and if you look directly above you, the point that is directly above you probably won't move. Whenever you spin around and you look up, the point directly above you will actually stay completely still. And that's what we experience every day here with Polaris. Polaris here is so still that as it moves throughout the course of the night, we've actually, over the last several thousand years, been able to predict where all the stars, the planets, and the moon will appear. We've been able to actually keep track of them, and we use this nice grid system you see here, which is known as the celestial sphere, to actually figure out where stars will be. So all of this stuff right here is called the circumpolar region, meaning that all these stars and all these constellations never actually rise or set. They just circle the pole all year long. And that's what they do. Very cool. I'm now going to go back to around 10:30 or so, and I'm going to remove our celestial sphere, which was just this button at the bottom here that says equatorial grid. You can also click E to get that to disappear. And I'm going to go ahead and close our date and our time window here. Now that we're back on Saturday night around 10:30 or so, what we're going to do next is we're actually going to transition to looking at our southern sky. We've been looking at our northern sky, but there's a lot of cool stuff we can see in the southern sky as well. So what we can do is I'm going to zoom out just a little bit, and easiest way to do this is to actually star hop. That allows us to keep track of what we've been looking at, and it allows us to find some cool new constellations and stars. So I'm actually just going to left click and drag so that we face the eastern sky. And as we do that, I'm actually going to direct your attention back to Ursa Major. So the back half of Ursa Major there, or the tail of the Great Bear, we can use as pointer stars as well. Just like we used these two stars right here to point us towards Polaris, we can also use these stars to arc us towards Arcturus. That right there is the brightest star of the constellation Bootes, or Botes. Bootes was a Greek warrior according to ancient mythology, but nowadays it looks a bit more like an ice cream cone. So we can use the bottom part of this ice cream cone here to spike us over towards Spica. And now I'm going to go ahead and click and drag and transition us over towards looking at the southern sky. And this spike here sends us right over towards Spica, which is in the constellation of Virgo, Virgo the Maiden. Now from Spica here, it gets a little bit hand-wavy or vague, but we can actually leap across from Spica over to Leo. And the star right here that we're actually leaping towards is Regulus, the brightest star in Leo the Lion. Now this may sound vague, but as I mentioned earlier, all of these stars that are brighter than the other ones, or larger than the other ones in our program here, are going to be visibly brighter outside. And we can actually test this. Earlier in the information, I had our magnitude pulled up. That's going to be this over here in the left side of the screen. And magnitude actually works like a golf score. So the lower the score of the magnitude, the brighter the object will be. So right here it says magnitude 0.95, and that's for Spica in Virgo right here. But if we go back to Arcturus, which looks a little bit bigger than Spica, its magnitude is 0.15, and that's over there in the constellation of Bootes. And then just for comparison, Regulus, which looks the smallest out of these three, is a 1.35. So yeah, it's the largest number and therefore the lowest magnitude. These three stars right here are actually known as the Spring Triangle. It's just a nickname that we give to groups of stars to help us keep track of them and help us know what time of year it is and that kind of thing. Over here in the southern portion of the sky, of course, you can also see the moon. Any object that you see here in Stellarium, you can just click on and then hit the space bar, and it will center on that object. Pretty cool. You can also zoom in on any object here, and this is where Stellarium gets very cool. And it will actually show you a nice HD image of what the object looks like in real time on this night. So I'm going to open up the date and the time window here again. And Thursday night, the 4th, was our full moon. So here we can see it's kind of waning away. So I'll go back in time here. There's the 5th. There's the 4th. And then it should start to look like a first quarter moon. And then a waxing crescent. And that's going backwards. So if we go forward from May into today, there it is. And that's how it's looked every day, and that is accurate. Now, you might be wondering what other things can we see besides the moon? Well, right now, in your night sky, you can see quite a few constellations, of course. However, you cannot see any planets unless you plan on going out kind of late at night. So let's get the date and the time window open again. And if we go out a bit later in the night, we'll be able to see not only Jupiter and Saturn, but also Mars. So around 2:30, 3 a.m., or if you get out really early, you could also see this around 4:30, 5, or 6, right before the sun comes up. We'll be able to see 3 planets. That's Jupiter, Saturn, and Mars. And just like with the moon, you can zoom in on any of these planets. You can click there, hit spacebar to center, and then just use your mouse's click wheel or your zoom in feature on your mouse pad there to actually scroll up and zoom into this object. And not only is it going to show us what Jupiter looks like at this time, but of course we can also change the time. So hour by hour, we can see how Jupiter's appearance will change, or minute by minute if you choose. We can also, of course, watch the moons of Jupiter orbit around Jupiter as we change this time. It's pretty cool. If we change around, if we change around like month by month or day by day or that kind of thing, you can see all the different surfaces of these moons and this planet. This one right here, if you're wondering what that spot is, it's the Great Red Spot on Jupiter, and it's a hurricane. That hurricane has been active for at least 400 years since Galileo first looked at this planet. However, it is dwindling away. This hurricane is decreasing in size, and pretty soon we don't know how small it could be. Right now it's still about the size of 1.5 to 2 Earths wide, so that's pretty large. Alright, I'm going to zoom us out of Jupiter here. There we go. And some other cool things that you can see. One of the coolest constellations is Scorpius the Scorpion. This right here is Scorpius the Scorpion. And it is going to be rising out a little bit earlier than this. Yeah, there we go. Around 10:30 you should be able to see Scorpius the Scorpion really well. And if you see this nice big bright orange star, it's not Mars. It's actually literally called not Mars. There in the ancient Latin and Greek they actually would see Mars pass by this constellation all the time. And so because Mars and this star here had a similar color, they were able to figure out which one was Mars, and then the one that they figured out was not Mars, they literally just called it not Mars. That's Antares right there. Mars is also known as Aries. So, cool little fun fact for you. The story that Scorpius comes from is actually a Greek mythological story where Scorpius was created to fight Orion the Hunter. Orion the Hunter, a wintertime constellation, was a great hunter and was supposedly the demigod of the sea, the son of Poseidon, and he made a living hunting and slaying all the great mythical beasts of ancient worlds. And so this upset many of the Greek gods and goddesses, and some of them created Scorpius, this giant scorpion that actually, I'm going to turn on the constellation art here to help tell the story. That's one of the buttons here on the bottom. Scorpius the scorpion there was a massive scorpion that Orion fought, and fought for many days and many nights until eventually they actually defeated each other in battle. And as a result of that, the gods put them both up into the night sky. However, only one constellation is visible at a time. So anytime you see Scorpius, you cannot see Orion, and vice versa. All right. So now what I'm going to do is we are nearing the end of our program here, so I'm going to open it up to questions here in just a moment. I just wanted to show you one more cool thing here, because some people are wondering, why is it that Mars passed right by this constellation here and got confused with that star, or why are these constellations here so important? The reason for that is because this is the area of the sky that the moon, the sun, and all of our planets actually appear to travel across. So we can go back over here into the configuration window, and I'm going to go over to, oh, excuse me, it's not the configuration, it is the sky and viewing options. And if we go to markings, we can actually click on ecliptic right here. It's just going to be this yellow line. I'm going to click ecliptic of date. And the ecliptic is the path that the moon, the planets, and the sun appear to travel across. So as we speed up our date and our time here, we should be able to see all of those objects line up right there with the ecliptic. If you've ever made a model of the solar system, you've probably seen that the sun is at the center, and usually all the planets will sit on these nice rings that go around the sun, maybe plastic rings, or maybe you made a mobile of the solar system one time. Well, those rings that the planet sits on are actually pretty accurate. All of the planets in our solar system will orbit on basically a flat plane, and from our perspective here on Earth, it looks like this, the ecliptic. However, one planet that does not is Pluto, and this is one of the main reasons why Pluto is a dwarf planet. Its gravitational orbit isn't strong enough to pull on the sun so that it stays on the same plane as all the other planets. It's actually very, very small, and as a result of this, it orbits at a very different angle. There are some other small planetoids and planetesimals in our solar system that we have called dwarf planets because they also exhibit this behavior. So Pluto is not the only dwarf planet. We do have 8 planets still. Pluto is one of 5 or 6 dwarf planets. All right, that is bringing us to the end of our Star Talk for today.